To run a structure search in SciFinder N, you have to open up the editor and draw your structure. There are multiple ways you can import your structure into the drawing tool. Here's a box where we can put in a registry number, a SMILES code, or an INCHI code. I've drawn a structure, and I'm going to load this into the CAS drawing tool. You'll notice there are no options for an exact search, a substructure search, or a similarity search. In fact, there are no options for any of those searches in SciFinder N. With the new platform and a new search engine, we can run all three searches simultaneously. The ability to review multiple types of results at the same time increases our efficiency. In the substance results, we can see the first tab contains the 10 exact structure results as drawn, and then we have about 19,000 subculture results, and about 10,000 similarity search results based on the Tanimoto algorithm. We've run all three searches at the same time, and now you can search and review answers from any three of the buckets as you choose. Looking at substructure results, we do have the ability to filter out these coordination compounds and metallocenes, or more specifically, use the Analyzed Structure Precision tab, where we can split out these substructure results either by conventional results, those that are tautomers, or Zwitter ions by selecting the appropriate facet. We also have other filtering options that can be used. One of the new additions to SciFinder N is a secondary drawing tool. We've added ChemDoodle in addition to the CAS drawing tool, which is the same as in SciFinder Web. We can access drawing editors in SciFinder N by selecting the Draw button, or we can pull an existing structure in SciFinder N into the drawing tool by simply selecting the structure, whether it's in reaction results or substance results, and selecting Edit Structure. This will open up either CAS Draw or ChemDoodle, depending on which drawing tool you had before. In ChemDoodle, the icons are different than in CAS Draw, but it has the same functionalities as CAS Draw. You can pull up your atomic table, as well as variables and shortcuts, the same shortcuts and variables as in the CAS drawing program. Same tools, templates, locking abilities, and so on. You can Any changes to one structure in CAS Draw will translate over to ChemDoodle. The main difference between the two tools is that ChemDoodle is touch-friendly. So now we can draw structures on a tablet, on a phone, with your finger, or with a stylus. SciFinder N is now untethered. All your searching, including drawing a structure, searching if you're on the go, can be conducted on SciFinder N. SciFinder N from CAS cracks the code of retrosynthesis planning. A new feature in SciFinder N allows you to easily perform a retrosynthetic analysis and quickly identify full synthetic pathways to known chemistry. All of this is fueled by the unparalleled reaction content from CAS. The search can be triggered in different ways. Let's start by drawing the target molecule in the embedded area. Click OK. Synthesis plans are created under the reaction query and we start the retrosynthetic search by clicking the button below the thumbnail image of the target molecule. The search results are typically generated very fast, but sometimes you may be redirected to the home page until the search completes. There you can view the status of your query, and you can also continue and carry out other queries. Once your search is complete, click to view the results. SciFinder-N generates the result set by carrying out retrosynthetic analysis, starting from the target molecule exhaustively using all the single-step reactions, and proceeding through the precursors until it finds commercially available building blocks or until it reaches a synthetic depth limit. The results are then prioritized, and the top-ranking route is shown first. You can drag and reposition the plan, and you can zoom in and out using the mouse scroller or using the buttons at the bottom of your screen. From this synthetic plan, you can start exploring the full set of synthetic options by selecting different alternatives to the individual steps in the plan. You can also start diving into the details of the reactions involved, and into the details of the commercial substances that are available. Synthetic search is to click any molecule on any SciFinder-N page. For example, the result set of a substance query. For any molecule that is a product of a known reaction, the retrosynthetic button will be available in the window that opens when you click the substance. CAS has leveraged its human expertise SciFinder-N has a new, novel way of grouping reaction results to allow our users to sift through large amounts of reaction results more efficiently. We can simply run a reaction search by drawing a reaction using the drawing tool, or by typing a registry number or chemical name into the reaction results. Select the dialog box and type in our search query, bimatoprost. Select the search button. In order to pull up reaction results from CasReact, our reaction database, you see we have about 500 reactions that we pulled up based on bimatoprost, a pharmaceutical compound. What we've done in SciFinder-N is group these reactions to 500 reactions. Instead of an index view showing every single one of the 500 reactions, we've grouped them now automatically by scheme, a scheme being a reaction with the same reactant as well as the same product. This would be considered the same reaction. The conditions may be different, and the bibliographic sources that we pulled a reaction from may be different, but we've grouped them together in the same scheme. So, Scheme 1 in this result list has 1 reaction. But Scheme 2 has 7 reactions. Scheme 3 has 5 reactions. If we wanted to see all 5 reactions, we could select View All to pull out those 5 specific reactions that have the same starting and ending material. But the point of this integrated scheme view is to save our users the time of having to sift through a large number of reaction results. Instead of having to see the same 7 reactions over and over again, we've automatically grouped them together so we can quickly go and review the first representative scheme and say, "This is what I really want to focus on," or I want to skip ahead to scheme 3 or another reaction. So, the scheme view saves our user a lot of time by grouping together reactions that are the same. We also have the option on the left, the fast SciFinder N, giving it additional content over standard SciFinder Web. Patents have always been part of the CA Plus reference database. What Patent Pack does is give our users the ability to take the next step and go to the full text patent document within the confines of SciFinder N, beyond the title abstract and index terms of a CA Plus reference record. Patent Pack currently covers over 30 of the major patent offices, so we have patent PDFs in multiple languages outside of English. A keyword search, a reaction search, or a substance search pull up references including patent documents that display the go to the record detail. Scroll down to the patent family table where we can select or a substance search, pull up references including patent documents that display the Patent Pack logo. View, we can use the pull-down menu to see what records we have available in the patent family. Another way to access Patent Pack is to go to the record detail. Scroll down to the patent family table where we can select which version. We also have the Patent Pack Viewer button as well. These will all open up a PDF to the first page of the full text document. Note, below we do have substances that were indexed from this document, about 400. Substances were located and indexed from this patent document. Each of these substances has a logo. If I select that logo, it will open up the PDF in a separate tab, and not just open the PDF, but go directly to the page that we indexed that particular substance from. You'll notice that we index from reactions, such as in this case, or from claim language or the chemical name of the substance. Also, if we find the substance in the table, we will index the substance from that form as well. So we're not just looking at structures. We're not just doing a format. We have them as thumbnails with the registry number, the structure, as well as the location. We can use these anchors to go directly to the full text page where that substance is located. And we can follow through the full text document on the right and read the full text as needed, as well as look at the substances for research purposes. Another benefit of Patent Pack is the fact that this PDF image has been converted to a searchable format via